So practical 5 is we can oxidize ethanol to produce ethanol and ethanoic acid. So if we want to produce ethanol from ethanol, then it will be partial oxidation. Whereas if we want to produce from ethanol to ethanoic acid, it will be a complete oxidation. So we need, for complete oxidation, we will use reflux condenser for this complete oxidation of ethanol to ethanoic acid. So what is the procedure for this? So oxidation of ethanol to ethanol, the aldehyde, that required distillation apparatus. To produce ethanoic acid, we need reflux apparatus. So example, what we do, we use oxidizing agent. So we place acidified potassium dichromate, which is an oxidizing agent, in a pear-shaped flask. So this is a round bottom flask is there. We can use a pear-shaped flask. This is a reflux condenser. So here also we are using a round bottom flask, that is a distillation apparatus. And cool down the flask in an ice bath. So first what we did, we use acidified potassium dichromate solution in a pear shape or a round bottom flask, and we cool down the flask. And after that, we add anti-bumping granules. Anti-bumping granules are making sure that there's a smooth boiling. The size of the bubble formed during the boiling will be equal, or not uneven boiling occur. So they prevent the formation of a large gas bubble that cause a violent boiling. Then what we do, we add ethanol dropwise to a pear-shaped flask and stir to ensure the complete mixing. Then, so first we have an ice bath. In the ice bath, we took this, add all this, and then we warm now. Warm up the flask to room temperature now. Then set up for reflux apparatus as shown here. This is a reflux apparatus. Then heat using a Bunsen burner for 5 to 10 minutes because the reaction is not a fast reaction, and allow some time for apparatus to cool down, and afterwards collect the product via distillation using the equipment shown in the diagram. So use thermometer to prevent the temperature rise too high. Keep the bulb in the vapor, never in the solution. Like here, when we are carrying out a distillation, the thermometer bulb is always in the vapor. It can never be in solution. So allow some time to cool down and collect the product. Then prepare an aldehyde. Conduct the same reaction under distillation without reflux. And for both reaction, the color change because chromium, it is potassium dichromate, acidified potassium dichromate, which is orange in color, and it changes to green. And alcohol will be oxidized to aldehyde, or it will be ketone. So this is how we do oxidation of alcohol into, or alcohol can be oxidized to aldehyde or carboxylic acid. But if it is like oxidation of secondary alcohol, it will be oxidized to ketone, and as a result we also use reflux condenser. Is it clear? Any doubt in practical 5?